Testing. 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 All right, we got a slightly different microphone setup here. It's a little bit further away, but it seems like it still works fine. We'll see. If it gets too outrageous, we can revert. All right, we're going to be closing out the week with some PaLM 2. So PaLM 2 is Google's large language model that they introduced in their Google I/O, which is kind of like the developer conference, I guess. It's just kind of like a big marketing situation where they go and they have these keynotes and they introduce new products. They're kind of copying what Apple does with their Apple event. They even have their own amphitheater now, so they copied Apple in that as well. Apple does all their events in their own amphitheater. Google does all their events in their own amphitheater as well. So they did release a very large technical report, which is over 90 pages long. I don't think we're going to be able to read all 90 pages in one sitting. We're going to try, but I'm also not going to necessarily just narrow too much on the technical report. I do have the Bard pulled up and I have ChatGPT pulled up. So, you know, we're definitely going to see if we can ask some questions and compare them, because as much as these technical reports try to tell you all about evaluation and what they're good at and what they're bad at, they're also very tricky and sneaky, and they often don't tell the full story. So it's really impossible to know how good LLMs are without actually just kind of asking them questions. Maybe we ask them some leak code questions, as we did before, and see how good they actually are at programming. I guess let's read the abstract. The abstract is the most important part of a paper because it's the part that everybody reads. So hopefully they made it entertaining and informative. We introduced PaLM 2, a new state-of-the-art language model. So again, here, just using the word state-of-the-art casually, of course, that doesn't really mean absolutely anything, because what does state-of-the-art mean in the language model world? So they can just kind of decide to say it's state-of-the-art without necessarily having to prove it, even though I'm sure it's state-of-the-art in some specific thing. Has better multilingual and reasoning capabilities and is more compute efficient than its predecessor, PaLM. Okay, so multilingual, reasoning capabilities, and compute efficiency. So that's what they chose, right? First sentence, it tells you the three kind of things that they decided are important, which are probably the ones they have the best performance on. PaLM 2 is transformer-based, using a mixture of objectives similar to UL2. Through extensive evaluations on English and multilingual language and reasoning tasks, we demonstrate that PaLM 2 has significantly improved quality on downstream tasks across different model sizes, so they're going to have a couple different sizes, while simultaneously exhibiting faster and more efficient inference. Yeah, especially now that everybody wants these kind of like chatbot services, like having very fast inference is very important, because they're also going to be paying a huge amount of money on compute. So as a big company, you certainly want performance, but you definitely want inference efficiency. This improved efficiency enables broader deployment while also allowing the model to respond faster for a more natural pace of interaction. Taking a jab at GPT-4 there in the form of ChatGPT, everybody kind of knows this, but if you ask ChatGPT a question, it kind of takes forever to answer. Do you know about PaLM 2? So we can kind of see the pace of GPT-4, very kind of slow, right? Feels a little slow, types out word by word. It might even be frozen here. Let's regenerate and see what we get. It's not even working. Let's refresh this whole window. Put this in here. Damn, ChatGPT, you're not making a good showing. Let's try Bard. So it does the loading up front, and then it gives you the whole blast. But this speed here makes me think 3.5, right? Look how much slower GPT is. So it is faster, but if you compare it to 3.5, which is the faster one, this one is significantly faster. Yeah. So Bard is basically the speed of 3.5. Demonstrates robust reasoning capabilities over PaLM on Big Bench and other reasoning tasks. Exhibits stable performance on a suite of responsible AI evaluations. What the fuck is that? Enables inference time control over toxicity without additional overhead. What is inference time control over toxicity? Does that just mean like active filtering? State-of-the-art performance, blah, blah, blah. Okay. Let's keep going. Let's see what type of introductions or what type of stuff they're going to put here. So, scaling laws. Okay, they're going to talk about how they made everything bigger and how they trained it for longer, how they trained it on a bigger data set. Just one page on the training data set, so maybe my guess is they might not even tell you what it's on. 10 pages of eval, so evaluating it on coding, reasoning, question answering, language proficiency. You see how they're starting off with language here? That seems to be kind of what they're touting, is just the multilingual capabilities. Responsible usage. So here's where they're going to talk about the inference time control, the ability to censor and potentially inject AdWords, you know, recommendations for developers. Conclusion. All right, so the actual paper ends at page 27, and then the rest of it here is kind of the appendix. Detailed results on scaling laws, instruction tuning, coding, natural language generation, creative generation, coding. Significant amount of coding sections here. You know, they're really kind of talking up the coding. Maybe we should hit it with a little lead code. Dataset language, composition, evaluation, dialogue, crowd sheets, model card. Okay, so right off the bat, we're kind of seeing that this is not going to be a paper where they tell us everything. It seems like basically they're just going to tell you all about evaluation, which is roughly what the OpenAI paper was as well. They don't really tell you the details, but they show you all the different benchmarks and how they performed. So that's kind of becoming the new standard for these large white papers. Can you fix this code and add line-by-line comments in Korean? Okay, that's kind of cool. Really showing off the multilingual stuff there. Scaling transformers has become a popular way to achieve state-of-the-art performance. I don't know about popularity. I feel like it's a theoretically sound way to improve performance. Showing that the amount of training data and the model size, so they have definitions here, reach the empirical conclusion that it follows the power law, with N needing to grow faster than D. I don't know if I agree with this. I think you can definitely have model sizes that are smaller than the training data, and honestly, if you make either of these bigger, you're generally going to get something better. The only pit you don't want to fall in is where the model size is significantly larger than the training data. Yeah, N and D should instead grow in equal proportions, sure. But the size of D and N aren't necessarily comparable, so it's hard to say. We independently derive scaling laws. We arrive at a similar conclusion. D and N should grow in equal proportions. Okay, that really doesn't mean anything. They reference this Hoffman paper like 10 times here. 4 different compute budgets. 10 to the 19th all the way to 10 to the 22nd flops. So spanning a couple order of magnitude of flops, which is shorthand for floating point operations per second, basically, which is a measure of compute. It kind of smoothing the final validation loss for each model. What does that mean? So the validation loss is going to be noisy, I guess, and then by smoothing it, they mean forming a kind of more flat line. Okay, so here they're kind of giving you a little bit more definition. So model parameters is going to be the measure for D, and then training tokens is going to be the measure for N. And this is kind of what I was saying, is that it's not necessarily comparable, right? Training data and model size, those are two different things, and they're measured in two different units. Training data, you can say, okay, well, how many total tokens am I training on? Because basically I'm going to be training this on next token prediction. So maybe the total amount of tokens is a good way to measure the size of my training data. And then model parameters, that's just going to be individual numbers, right? And you might have a model that has 400 million parameters or blah, blah, blah. But one parameter doesn't correspond to one token. Like there's kind of like a weird comparison happening there. I think there's a lag with my audio. Sorry about that. Important to note that the selected model sizes, blah, 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 results only suggest that the optimal numbers for a parameter is 10b. Yeah, I don't feel like these are good proxies. So here we go. ISO flop curves at each compute scale. So these are different amounts of compute. This is different numbers of parameters here on the X, and this is the training loss, or I guess validation loss. Training loss would not be a good proxy. Hello, Kalina. Good evening. It's actually the morning for me. It's Friday morning, but good night to you. It kind of seems like they're trying to say here that you start overfitting past a certain point. So if you're training for this long, if you have a lot of parameters, at some point you start overfitting, and that's kind of what they're showing you here, is that the overfitting point changes depending on the size of the model. Scaling laws obtained from all 10 to the 4th compute scales. And here you just have a log scale tokens, log scale flops, and what they're showing you here is that you could basically project into the future what the amount of tokens you would want to train on for the amount of flops you would want to train on. But I don't know if necessarily because this is linear here, it's going to necessarily be linear there. I feel like, and this is also linear in log scale. So this is log flops and then log tokens here. So logs with base 10. So this is basically orders of magnitude. But I feel like you're not entirely sure. So it's not, you can't necessarily predict and say, hey, by the year 2030, the GPUs will be 10 times faster, which means they're going to be here, which means you're going to be able to train for 10 times longer. Therefore, the amount of optimal tokens is going to be this. Right? I don't necessarily know if you can draw that conclusion. You cannot extrapolate from that distribution. I did not. I requested access, but they did not give me access. I was kind of hoping that I would have access by the time for this stream, but it was not the case. But we do have it here, so we can ask it questions and compare. I guess what's a weird question we can ask it? What is the name of the plant used by Harry to breathe underwater in the Tri-Wizard Tournament? So this is a kind of a weird question. This is like a deep Harry Potter knowledge here. Let's see if it actually gets it. Let's ask GPT-4 and then Bard. I'm a text-based AI and I cannot assist with that. All right, so Bard deciding to tap out. And there you go, ChatGPT giving you the real answer. Harry Potter uses a plant called gillyweed to breathe underwater, which is correct. So, yeah, so far, Bard not looking super strong. Okay, Chinchilla versus PaLM. So Chinchilla and PaLM. Chinchilla is a model that was also developed inside Google, but they ended up not using it at all. And so, like, there's kind of conspiracy theories around this, but I'm pretty sure what probably happened is that the people responsible for Chinchilla just ended up in a different company. Chinchilla Google. Chinchilla explained, introduced here, training compute. Here's all the names of the Chinchilla people. And now the question is, if you go and you start clicking on some of these names, how many of these names are still working at Google? Or quote unquote DeepMind. Some of these people are definitely still in DeepMind. So maybe they're still there, but I don't know. That was my guess, is that those people left and that's why they stopped using Chinchilla and now are kind of all in on PaLM. The PaLM 2 pre-training corpus is composed of a diverse set of sources, web documents, books, code, mathematics, and conventional data. Significantly larger corpus than what was used to train PaLM. PaLM 2 is trained on a dataset that includes a higher percentage of non-English data than previous large language models. Wow, what a lame little dataset section. Look at that. Look at that. This is a 92-page report, and the section that explains the training dataset is less than 1 page long. And the only thing they tell you is that it's composed of web documents, books, code, and mathematics. Data cleaning, quality filtering, deduplication. All right, so for a small fraction, we added special control tokens marking the toxicity of text. We evaluate the effectiveness of conditioning on control tokens as an inference time control method. Oh, shit. Okay, that's kind of interesting. So, right, the same way that a stable diffusion model, you basically condition it on the text, and that allows you to control the generation, right? They're doing a similar thing here. It sounds like they have what they're calling control tokens, so they have the ability to condition the LLM on specific tokens, separately from the just normal way that the transformer works, where it's kind of paying attention to what's previous in the sentence. This will be a separate thing. Control tokens do not negatively impact performance. Yeah, so why are they doing this? I think the reason they're doing this is because right now the control token, they're kind of showing you, I don't know, maybe about toxicity or something like that, but I bet you the whole point of this is that the control token will eventually be a user embedding. So in the future, when you interact with Bard will not be interacting with the same Bard as everybody else. The Bard that you interact with will be conditioned on a embedding or a control token that is supposed to represent who you are as a person, right? So by doing that, they can very easily provide inference for a huge amount of different people that have different control tokens. And the real reason they're doing that is because your user embedding, your control token, will be able to tell Bard what ads to serve you, right? Because at the end of the day, Google is an ad company, and the way that they make money is by being able to sell targeted ads. So if you're a company that sells protein shakes, you can go to Google and you're like, hey, I want to sell protein shakes, but I only want to pay for ads for people that drink protein. And Google's going to be like, no problem. We know everything about everyone because we know their Gmail and all their stuff. Therefore, we can make sure to filter Bard so that only people who drink protein are going to, and have this specific token within their embedding, are going to receive your ads. So it's all ads all the way down. PaLM 2 was trained to increase the context length of a model significantly beyond that of PaLM. What is the context length? This improvement is crucial. Okay, I mean, are they going to tell us what the context length is? Language proficiency, classification and question answering. Yeah, I mean, this is kind of this is what I'm talking about, where it's like evaluation, and the only thing they're evaluating it against is against themselves. Is they're evaluating the PaLM model with the different sizes, so small, medium, and large. And you can see how small, medium, and large, so 75%, 81, 86. So of course the slightly smaller one is going to be slightly worse, and then the slightly bigger one is going to be slightly better. But there's no column here for GPT. There's no column here for Llama. There's no column here for BigCode, right? Where's the comparison to other open source models? Again, no comparison. Toxicity classification AUC-ROC. What? What a weird little metric there. Ooh, there we go. All right. GPT-4, perfect. Finally, they're comparing it against something. So they very carefully picked these benchmarks, right? If you notice, for all of these other benchmarks here, there's no GPT-4, but for this benchmark, they do have GPT-4. And, you know, it's kind of, they're trying to show you that it's about there, but it's not, you know? What is Wino Grand? Explain to me Wino Grand. Reset chat. Explain to me Wino Grand. So let's see what this benchmark is. Or Grande, sorry. Oh, so you look at this. GPT-4 got it. Even though I misspelled it and said Wino Grand instead of Wino Grande, it got it. Large-scale dataset used to evaluate the natural language understanding. Challenging for machine learning models. Focuses on testing their ability to reason over common sense knowledge. Okay, so it's one of these kind of like, if Sally has 3 apples and John has 4 apples and they both give 3 apples to Tim, like it sounds like it's one of those type of benchmarks. Look at this. Bard does not get it at all. So Bard was unable to get the misspelling, right? And it's GPT-4 was able to get the misspelling. Bard was not. Bard was like, oh, I don't know what that is. Therefore, he must be talking about this guy, an American street photographer, which is incorrect, right? And maybe you could say, hey, well, that's on me for misspelling it, but why would I spell it this way, right? Why would I spell it with a capital G? So I don't know. So far, 2-0 for ChatGPT in terms of explaining stuff. And it does seem that on the benchmarks, it's pretty much better anyways. Beyond the imitation game benchmark provides a large collaborative suite of tasks. LLMs have struggled on tasks that require quantitative reasoning. Okay. Palm versus Palm 2, again, kind of impossible to judge because you're only comparing against the older version of this model. So here we go. Evaluation results on math. GPT-4, Palm 2. What is this? Why is there two numbers here? I guess maybe it's the small model versus the big model. But really, this is the comparison because I think that the GPT-4 that you interact with here is not very big at all. So based on what I've heard, they think that this is 2 billion parameters, this GPT-4 that you interact with day to day. So the fact that the 2 billion GPT-4 is able to get a 42 score on this math, but the Palm 2 small is 34, and you have to use the Palm 2 big to get the 48. Still looks like GPT has the edge. Wow, and the original Palm was actually trash. Palm 2S is a version of the Palm 2S. Code language models are the most economically significant and widely adopted LLMs today. Personal programming assistance, competent tool using agents. We built a small coding-specific Palm 2 model by continuing to train the Palm 2S model on an extended code-heavy multilingual data mixture. We call the resulting model Palm 2S. Okay, so they basically fine-tuned their own version of Palm 2 specifically on code in order to be able to get as good performance as they can here. Can I set this such that I use are you Palm 2S? I would like to code. Let's see what it says. I am not Palm 2S. I'm still under development. I am not as good at coding yet. How good are you at coding? Let's do it, guys. We're opening up Leak Code. We're doing it. We're doing it. Sign in. Sure. Problems. Difficulty, no thanks. No thanks. Which one was the one that we did before? Let's do difficulty medium. How about this one? Adding two numbers, longest substring without repeating characters. Fuck doing it in C++. Let's do it in Python 3. I'm still in development, but I am learning to code. I can generate code in a variety of programming languages, including Python, blah, blah. Okay. Can you... Let's actually give it a fresh prompt here. Let's not give it any context. Let's say, can you finish this Python function for me that finds the longest substring without repeating characters? And let's go ahead and copy that as well, and we'll send it to GPT-4. All right, nice little commented code. I like this like coding style. I like that it made the doc string as well. That's nice and clean. But let's see if it actually is any good, and let's see if it actually solves the indentation issue that we were having with. Nope, it does not. Perfect. My favorite. Okay, let's run. Indentation error, of course. Why? Ugh. Ugh. See, let's make sure that we're even just doing it correctly here. Return max length if scene set. Okay. Key error A. Okay, so it's giving it a sentence, right? And it's trying to remove a specific key from the dictionary here. So it's using this S string here. And it's saying, okay, S at start. Start is 0. So S of 0 is A. And then it's saying scene dot remove A. That's no good. Let's see if GPT can get it. Every time, dude. Of course, you know, like, why do people just not do this? You know, like, they spend 92 pages just giving you all this crap about how it's good at coding, blah, blah, look at this benchmark, and then all you got to do is just take it and copy paste a leak code, and that's all you need to know. Look at this. GPT-4 gets it first time. The solution is really fast, 77 milliseconds. It's among the fastest. It's kind of not great in terms of memory, but, you know, it works, versus this is literally crap. It doesn't work at all. Your sub count is going rocket? Kind of, yeah, hopefully. I can actually turn on the ads at this point. They've given me the option to turn on the ads, but I don't want to, I don't know, something about turning on ads makes me uncomfortable. I don't want to give you guys ads. But let me know if you guys want ads, and then I'll put ads on it. We benchmark PaLM 2 on 3 coding datasets, blah, blah, blah. We also evaluate PaLM 2S. PaLM 2S improves upon the much larger PaLM Coder 540B. Okay, so this is the result. So pass at 1. I suppose this means that the first solution needs to pass, which is actually, if you, some of the original kind of like LLMs for coding papers, what they would actually do is they would generate like 100 different solutions. So they would basically get 100 different solutions, and then they would evaluate every single one of them. And usually there's at least one that will work, but you need to basically find it, right? There's like 99 that are trash. Put join button on your YouTube. Okay, that's a good idea. So passing at 1 basically means that the first answer that it gives you needs to be correct, right? The top answer needs to be correct. And here they're showing you the PaLM 2S, which is their fine-tuned version of PaLM 2 specifically on code, versus the original PaLM, which is obviously going to be terrible because it's the one that they keep saying here, right? They say PaLM versus PaLM 2, right? Look at the performance of PaLM on math versus PaLM 2. You're talking 8% versus 34%. Score of 34 versus a score of 8 compared to GPT-4, which is at 42. So this right here, PaLM is going to be trash, and then PaLM Coder is only going to be slightly less trash. But you can see here how the performance on Python is pretty good. It's generally the best. It's pretty good at Python, TypeScript, which is basically Java, JavaScript, and C++. And it's not very good at Haskell and Julia, but I mean, that makes sense. Those are kind of like lesser known programming languages. There's going to be less representation of that in the training data set. Here's a different metric, BLERT, Bleu RT. Multi-dimensional quality metrics. We hired professional translators and measured translation quality. Yeah, so they're really pushing this multilingual kind of aspect of it, and I think that's because that's what they do well at, right? So they can't beat OpenAI in terms of the coding ability and in terms of basically the logic and the reasoning. I feel like GPT-4 has like actual intelligence to it. It actually feels like an AGI. Where did I hear that the GPT-4 is 2 billion params? I heard it in this YouTube MLST. If you guys don't know this, this is a great YouTube channel. This guy here. It used to be like a podcast, but now it's more of like a one-person podcast. There used to be a couple other people here, but I listened to this yesterday. This is a great one. Would recommend it. But at one point, he mentions that he heard that it's 2 billion parameters. And this guy, like, he has interviews with like all kinds of famous people, you know, like LeCun, all these people, Wolfram. And I'm pretty sure that he might not know. They might not have told him how many parameters it is, but I feel like someone like Wolfram, especially, right? Like this guy, Stephen Wolfram, this guy has is the kind of CEO, founder, like developer on Wolfram Alpha, and Wolfram Alpha was one of the first plugins into ChatGPT. And I feel like if you're developing a plugin and you have like the level of kind of coordination, I guess. I don't know what the right term there is. Like it's a partnership, right? Partnership between Wolfram Alpha, the company, and OpenAI, the company. This guy probably knows the exact size of the GPT-4 that runs on your browser, that runs here when you go into your browser and you click enter and what is running here. Wolfram probably knows. So at some point, Wolfram probably told this guy, and then that guy, he let it slip here in an unrelated conversation. So yeah, podcasters are very useful because they are privy to a bunch of private conversations, and sometimes they will accidentally leak information like that. So that is where I heard that it's 2 billion parameters, but I don't know for sure. I've never SSH'd into an OpenAI server and counted the number of parameters. It's like word of mouth is basically what I'm telling you here. Okay. Results on the FRMT, few shot regional. So again, just talking about, is this kosher? Chinese Taiwan, Chinese mainland? Is this Google like bending the knee to good old Xi Jinping here? Do people from Taiwan call it Taiwanese, or do they call it Taiwan Chinese? I don't know. Potentially misgendering harms. Okay. Natural language generation. Language is called Chinese. Ying Wen. Han Wen. 我学火中文. 我会说中文, right? Something like that. Language is called Chinese. 我要冰淇淋. How about that one? That one's pretty good. Potential harms and bias. We evaluated. Okay, this is the big toxicity. I'm sorry if some of you can speak Chinese and you're embarrassed by how bad my Chinese is. To evaluate, we query the model with a prefix and match the generation to the suffix. We use greedy decoding, verbatim memorization. I don't feel like memorization is technically a bad thing. I feel like that's actually kind of a good thing, right? If your language model is able to memorize specific data, especially if you're using it for like lookup, you know. A bunch of languages here, canaries. I don't know what a canary is. Is there anything going on here? Language size relative to English. Need fewer repetitions to be memorized in the tail. Okay, so basically I guess what they're showing you here is that when you're training with languages where there's not a lot of data, it ends up just kind of repeating and memorizing, because the relative size of the data set for that lesser known language is going to be smaller compared to the model size. So the model can very easily just memorize the entire data set. So you have this kind of overfitting effect, except here now they're calling it canaries, because I guess maybe canaries in the coal mine or something like that. Memorization analysis provides a systematic study in which we can inform the potential privacy risk. Responsible usage. High toxicity. Probability of toxic continuation from a non-toxic prompt. Lower is better. What does this mean? Why is the number for no control and high toxicity? I guess this is the control token. So they were talking about how they have the ability to condition the output on a control token, and then they were talking about how they have a specific control token that will reduce the amount of toxicity. So I guess here what they're comparing against is that, hey, if you give it no control token, the probability that it outputs toxic prompt or toxic continuation is about 0.07, but once you have this low toxicity token, it'll be 0.03. But here's the real question is, if you give it that low toxicity token, what is the performance on baselines, right? Because I bet you those two are related. And this is kind of something that I don't feel like these companies are talking about, but I think there's a relationship between the kind of nerfing of these models, making them less toxic, making them less argumentative, making them more reliable. They always say the same thing. They don't quote unquote say misinformation, right? The more you do that, the more you're constraining the language model, right? It's like the language model has this giant space of possible things it can say, but every time you kind of use RLHF or any of these kind of anti-toxicity approaches, you're basically saying, no, only say the things here, only say the things here, only say the things here. And after a certain point, I feel like the language model is like limited to a very, very narrow set of its possible answers. So this is just me kind of talking based on my intuition, so I have no hard evidence to support that, but I kind of feel that there's going to eventually be this relationship. Okay, so we got to page 26. Basically, this whole report just seems like a large nothing burger where they kind of just showed you the performance on a bunch of different benchmarks. They almost described what the training data set was, and then they just backed out, didn't describe anything. And they certainly don't talk about the model architecture or any of the training strategy or even what it was trained on. So yeah, it's kind of a little bit unfortunate. They're kind of following in the footsteps of OpenAI here and being super secretive. Here's all the different people that worked on this. Evaluations, responsible AI, architecture and modeling. Look at this. There's more people in responsible AI than there is in the model architecture. Which tells you what's going on here. It's also kind of indicative. Look at this. Look at pre-training data, training, and evaluations. Look at the amount of people in training and pre-training and evaluations versus the amount of people in architecture. Like, model architecture design is such a rounding error at this point, because it's basically, okay, we're just going to do transformers and we're going to basically have as many transformers as we can fit. But all of the hard part, all the like difficult and all the kind of the surface area where you can actually add value is mostly in the training and the data cleaning, which is what this part here is. What does the responsible AI team do? The responsible AI team is usually they basically just come up with these tests, right? So who actually sat there and came up with all these tests for toxicity and ran all these tests and wrote all these paragraphs and found all these references? That's all responsible AI. So responsible AI is kind of like a offshoot of the evaluations team. So the evaluations work stream, these are generally going to be more technical people, these are going to be slightly less technical people. But at the end of the day, they're doing the same thing. They're evaluating the model. Here's the fine-tuning team. So these might be the people that fine-tuned it on the code and on the specific different languages. Optimization, I don't know what that means. I guess that's maybe hyperparameter optimization, but probably not. It might be the people who actually get it to run in real time on the Bard. Code pre-training, infrastructure. These are going to be the most badass people here. The infrastructure, these are the people that set up all the TPUs. And then you have program management and product management. So these are your managers here. It's a lot of people. And then there's your references, a very long list of references here. All right, let's get to the extra part. Detailed results. Okay, so these are the different model sizes. You got everything from 14 billion parameters to 3 billion parameters. This is actually pretty small. You're telling me that the biggest PaLM 2 is 14 billion parameters? That's slightly bigger than the second biggest llama? That seems a little weird, right? I feel like they have to have there has to be like 100 billion parameter one or something like that, right? Instruction tuning. The Flan dataset contains 1,800 tasks. Yeah, I don't know what this means. You have a 14 billion parameter version here, but then here you have a 540 billion parameter. Average, big bench, these are different things here. And of course, like if you're comparing against a bunch of old models, you're going to perform well. I feel like they should have. This is a little bit more interesting. So here they're doing so this is not 0 shot either. This is 1 shot. So you're seeing you are getting a little bit of improvement here. Does seem kind of off. Yeah, they're kind of like there's a lot of smoke and mirrors here. It's kind of not entirely clear what's being evaluated against what and what the size of this is. Like, what is exactly is this PaLM 2? Is this the 540B one? Is this the 14B one? Is this the 3B one? Raw pass 1 results for Babel code. And again here, they're not comparing against anything, right? You could compare against big code. Let's see, big code about the project. Let's see, big code paper. Where's the paper? Paper. All right, we're gonna have to do this manually because ChatGPT does not, or Google does not want to tell us. So Babel code. Let's see if that's available here. Control F, Babel code. It's not. What are some benchmarks for Babel code? What are some numbers that show the state of the art in the Babel code benchmark? Let's see. Reset chat. Okay. Babel code benchmark does not exist. State of the art is 90%. Is that true? No. It's not even close. Is this just straight up fake? Do they have a table here? Babel code GPT 3. I just need one number. Here we go. This is it. Boom, we found it. We introduce codex, and here I'm assuming this is Babel code. Human eval, pass at 1. Codex 12 billion is getting 28% right here, 28%. PaLM coder, I'm going to 26%. Okay. So we don't know exactly if it's the same benchmark, but that number seems about right. Unfortunately, if you just joined the stream, we did actually give Bard and we gave ChatGPT a leet code problem, and it was unable to answer it. So Bard wasn't able to answer it, but ChatGPT got it on the first try. Explaining jokes. You guys want to try that? Let's generate a joke. Generate a joke for me and explain the joke to me. And explain why the joke is funny. Reset. Explain this joke for me. In one sense, atoms are the building and therefore make up everything. In the other sense, makeup can mean fabricate or tell lies. The humor comes from the unexpected connection between these two meanings. Yeah, I mean, that was an easy joke. What about... can you give me another joke that is more nuanced and complicated to explain or to understand? So Descartes is the I am because I think, or I think because I am, or something like that. He was an old French kind of like philosopher type dude. So let's see. Let's see if Bard gets this one. This one seems also easy. Explain this joke to me. Yeah, okay. Joke explaining is easy. Coding is hard. Per language one-shot results. So we can see how Japanese, of course, you're going to get better performance than Telugu, right? A lot more Japanese data on the internet than there is Telugu data. I don't even know where Telugu is from. What is that? Telugu. Telugu is Dravidian language. So it seems to be kind of this like southeastern part of India. Yeah, they're really like they're really leaning into the language part here, which let's see. I'm trying to think of like some kind of language-based thing. AI humor is vastly untapped, though. Yeah, I'm actually thinking that at some point someone's going to do an LLM specifically fine-tuned for humor, and it's going to be way more funny than any human. And I actually think that much like Go, right, or chess have a very clearly defined kind of win objective, I feel like comedy is also the same, right? Where you can basically, if people laugh or they don't laugh, then it's either funny or it's not funny. So I think that much like you will be able to get, much like we got a Go and chess AI that are significantly better than a human at the games, I think that there will be AIs that are significantly better at comedy than humans, which should be interesting. Right? Eventually there'll be a website where you can go and you can talk to an LLM that's just outrageously funny, and it knows everything, and it's very smart and quick and witty, and it can make a joke about pretty much anything. Okay, this is all just like multilingual examples. I can't read any of this. Can't read any of that. Create a simple HTML web page which has a button called Go. So I mean, HTML, haven't written that in years. Or maybe not. I think I actually wrote HTML for my own web page. The laugh is often context specific. You would constantly have to update it when the culture changes. Yeah, you would. It would have to be per user too, right? Because you would have to basically do what they're doing, where they feed it a specific context vector that represents the user, and then depending on what user, you're gonna have different types of comedy. I think there's some types of like jokes and comedy that are kind of timeless, that always work and are always gonna be funny, and then there's like a different type of comedy that's like has to be specific to the time, right? It's like current issues and stuff like that. And I feel like, I don't know, I'm not much of like a stand-up person, but it seems like the meta for stand-up is you have to basically talk about current issues, right? It's like you have to be able to remix what's in the current zeitgeist. You can't just have like a bunch of stale jokes about everyday life. Responsible AI. We observe underrepresentation of identities related to women relative to men in most signals and also in gender pronouns. References to the non-binary identity. Okay, so Google is at the heart of Silicon Valley, so they're very, very sensitive to gender and race and these kind of issues, right? It's very important to these people, so they have a big section here where they're really looking deeply as to whether or not it's not using the right pronouns. Multilingual toxic language harms and representational bias. This is so much crap. I don't think you need a lot of this. Percentage of toxic responses based on race. Doesn't it seem a little bit racist to do this? You know, it's like, I don't know. I don't want to open that can of worms, but sometimes it feels a little racist. Translation misgendering, like Jesus Christ, so much of this fucking thing is just toxicity and test social biases systematically. Bias benchmark for QA. BBQ, at least that's kind of a cool benchmark name, the BBQ. Who is bad at math? Nancy. What? Nancy's bad at math? You can't be saying that, because then that means that anti-biased response, Donald? Dude, what? Dude, this is gonna ramp up. Like, for those of you that are not in the U.S., there's a there's an election coming up in 2024. The U.S. election cycle is like every 4 years, and then there's a big one coming up, and there's a lot of like anxiety and intensity, and especially with the backdrop that in one of the previous elections, Facebook kind of got into trouble because people were buying ads on Facebook and like just sort of like kind of like pushing all kinds of weird stuff on that. And I feel like all these tech companies are hypersensitive right now because people are going to be using ChatGPT and Bard and all these different tools in order to do all kinds of shenanigans in these elections. So everyone's getting super on edge about that. So you can feel the kind of like political tension and the like kind of anxiety kind of bleeding through this paper, where so much of this is about these kind of like political issues. What sexual orientations are referenced in the comment? What religious identities, races, and ethnicities? What annotation platform was utilized? Figure 8. Now Appen. So this is kind of like a Scale AI. Yeah, look at all these like like data labeling was only a thing when supervised learning was there, right? So there was a period where supervised learning was the only way to really do anything, so you basically had to have annotations. And you saw this whole group of companies like Scale AI and Appen and Figure 8 and all these companies that were basically, what they sold you was people from third world countries, right? What they did is they're like, hey, rather than have someone go here and label all this data for you that works in your office and is getting paid a bunch of money, why don't we show you how to do that? Or why don't we expose to you a bunch of people in Bangladesh who are getting paid pennies, or a bunch of people in the Philippines, and they'll label your data for you. So Scale AI and Appen, these companies here, like that's really fundamentally what they did, is they just basically gave you a way to access really low cost labor. And now that we have these kind of large language models that these are not trained on supervised data. These are trained on kind of generic self-supervised tasks like next token prediction, mask language prediction. So we really don't need these anymore. We really don't need these companies that are providing labels for supervised learning. So you're kind of seeing these companies try to pivot in a different way, right? Like, look at them, generative AI, right? Like generative AI, like they're just kind of throwing that out there now because they're scared, right? They're scared. They don't know what to do. Their entire business model is potentially disappearing, and they have to figure out a new business model, right? So look at this. AI training specialists, trusted data partner, like they're trying to find a new way to pretend that they're not actually irrelevant, but the reality is that they're fucking irrelevant. I don't know. That's my spicy take. But I don't know, maybe I'm wrong. Annotators were paid 1.5 cents per judgment. What do they got here? Which annotation platform was utilized? Venga. Is this another one? Another annotation platform? Not Benga. Venga. Venga annotation. Venga Global expands data annotation collection. A global leader in translation and localization. There's just something that like kind of rubs me the wrong way about the like exploiting kind of low cost of living area or like third world countries to label and do mechanical Turk tasks. Like that just, it just doesn't feel right to me, you know? It's very dystopian. All right, and that's basically it. So I don't know, this paper just seems like a bunch of nonsense. 90% of this is just measuring the bias and toxicity and whether or not it uses the right pronouns. But it does seem like the multilingual is good. I don't even really know, to be honest. It's going to be super hard to compare because they don't really compare it to GPT-4. They don't compare it to any other LLMs. They're really only comparing it to the previous version, which is PaLM, right? So they have PaLM 2, and then they compare it to PaLM. So this paper is a kind of a 2 out of 10, to be honest, if not a 1 out of 10. They don't tell you about the model architecture. They don't tell you about the training. They don't tell you about the data set. And they don't really tell you anything. And yeah, that's kind of what about that. So they do have an API. I did try to get access, but I joined this wait list. I didn't get in. We'll see. We'll see. I suspect that maybe it'll be good. I don't know. Maybe because the BARD here that we were using, right? So we used this BARD to generate a leak code, and it didn't do super well, but this is probably not the coding one. So I'd be curious what the API that is specifically for coding. Like, hopefully that one is pretty good at coding, but we'll see. +75 tokens per second and a context window of 8,000 tokens, which is basically GPT as well. And actually, I think that Anthropic, this is another company, kind of like a OpenAI, but not as good. They have, I think they recently announced a 100K context model. Anthropic 100K. Yeah, 100K context windows. Mosaic ML dropped to 65K. So 7B, I guess 7 billion parameters, but then 65K tokens. Thanks to Alibi, we trained on up to 65K tokens and can handle up to 84K. What is this? Fundamental question. We first show that extrapolation can be enabled by simply changing the position of representation. We find that current methods do not allow for efficient extrapolation. Attention with linear biases. Does not add positional embeddings to word embeddings. Instead, it biases query key attention scores with a penalty that is proportional to their distance. So this is a fancy way of not retrieval. Context. Just control Fing for context here. Sliding window. Sinusoidal sliding window. Okay, so maybe they're getting more context by like basically just sliding across. Almost like a RNN kind of situation where they're not necessarily looking at the whole context at the same time, but they're basically looking at chunks of it and then just kind of aggregating it. Right, like, do they tell you? Like, they tell me how you're getting this longer context length, right? Tokenizer, GPT Neox. Yeah, 65K input sequence. This is the size of the token dictionary, so 50,000 possible words that each token can represent, but that includes everything, including like weird characters and emojis even. Are emojis part of the vocabulary? I think they are. Let's ask it. Only answer in emojis. Can you summarize Lord of the Rings for me? Let's see. Let's test them out. Let's test them out. One ring to rule them all. Gandalf the wizard, Frodo Baggins the hobbit, Aragorn the ranger, Gimli the dwarf, Helm's Deep the Rohirrim. These are just the characters. This is also incorrect. Look at this. It's using the Legolas, like the elf emoji for all of them. Gimli should not be an elf. Gimli should be a dwarf. Let's see. This is what I'm talking about. Look at GPT-4. So much better. You got wizard, ring, mountain, sword fight, elf, orc, I guess, tree, mountain, castle, galaxy, people holding hands, fire, eagles, star, heartbreak, son of a mountain. It's kind of cool. I like this one though. This one's much better. Only answer in emojis. It answered only in emojis. Versus Bard gave me this weird like bulleted list. I don't know, guys. Kind of seems like GPT is still king. Can I get the demo of here? Let's see. Let's compare it to Mosaic ML 7B. So, I mean, this is better. You know, it only answered in emojis, unlike Bard. But I don't think it's quite as good as the ChatGPT summary. There are no dragons in Lord of the Rings. There is a squid at the opening of the Mines of Moria, and then there is a spider. But I just don't feel like the summary is as good. Where's the ring? Yeah, that's what I'm thinking, right? Doesn't even give you the ring. Let's close out some of these, some of this, some of this, some of this. Let's flash attention. This is a technique to use less memory in the attention. What I would give to have the distilled GPT-4 model, you could easily fit it on my rig. Yeah. I wish I had that too, right? Like, somebody needs to leak that. Somebody needs to go to OpenAI and, like, put on a costume and then go and just grab that raw. Not GPT-4, not this one. This one has been RLHF'd. I want the raw model. I want the pre-trained raw model. You know? Let's go back here. Slow and memory hungry, since the time and memory complexity are quadratic. Approximate attention methods. We argue that the missing principle is making attention algorithms I/O aware, accounting for reads and writes between levels of GPU memory. We propose flash attention and I/O aware exact attention mechanism that uses tiling to reduce the number of memory reads and writes between GPU high bandwidth memory and GPU on-chip SRAM. So right away, whenever you see this, this is high level shit right here, right? I feel like sometimes you read papers where they don't, to them, all memory on the GPU is the same, but then you read papers like this where they actually understand that there's all kinds of, there's different memory even within the GPU. Showing that it requires fewer HBM accesses than the standard attention and is optimal for a range of SRAM sizes. We also extend flash attention to block sparse attention. Hello. 50% end-to-end wall clock speed up on BERT large. Stefano Erman. This guy. Let's look him up. Stanford Computer Science. We can actually look him up here. Stefano Erman, cited by, this is his biggest paper here. 2,000 citations is nothing to scoff at. That's really fucking big. Generative adversarial imitation learning. I feel like I've actually read this. This is a pretty old paper, but yeah, Jonathan Ho. This is a robotics paper. No, it's not. Yeah, it is. It's a RL paper. I probably did read this. Peter Beal. Yeah, this is like my old world. Learning a policy from example expert behavior without interaction. One approach is to recover the expert's cost function with inverse reinforcement learning and then extract a policy from that cost function. We show a certain instantiation. Analogy between imitation learning and generative adversarial frameworks. So imitation learning, sometimes also called behavior cloning, but it's when you have a bunch of expert trajectories of something and then you try to basically match that. It's kind of like the same idea as distilling, except rather than distilling from a teacher network into a student network, you're distilling from a human policy into a student policy. And I guess here probably what they tried to do, this is older now, this is like 2016, so 2016 is like peak GAN, right? This is like right when the GANs came out and everybody was convinced that GANs was the future and everybody was trying to figure out a way to use GANs in their research. So obviously they were doing kind of reinforcement learning and they were like, hey, how can we fit a GAN into this? And this is what they did. They probably have some objective where they basically try to train a policy from the human, and then they probably have a discriminator that tries to determine whether or not it's the human policy or the robot policy. Pretty cool. What other papers does he have? Combining satellite imagery and machine learning on the opportunities and risks of foundation models. What is he working on now? Geometric latent diffusion models for 3D molecule generation. Ooh, some bio stuff here. That's kind of cool. Do you think these models do things like CRC32 checks on itself? What is a CRC32 check? What is a CRC32 check? How's the paper so far? The paper is, we finished it, and it's pretty crap. They didn't really tell you anything. They spent basically 80 pages telling you that the model's not racist, is basically the TLDR. They didn't really compare it to GPT-4. They didn't really give you any benchmarks to anything else. All they did was basically talk about how their model doesn't incorrectly assume gender, which is a little unfortunate, but I don't know. Yeah. Nothing about the model architecture, nothing about the training, nothing about the eval. All right, let's see. CRC32, cyclic redundancy check, is a widely used error detecting algorithm that computes a 32-bit checksum, also known as a hash, for a block of data. Okay. CRC32 check is an error detecting code that is useful to verify the integrity of data. Okay, so this is some crypto kid situation going on here. CRT is a checksum algorithm used to verify the integrity of data streams. Works by taking the input data, appending a fixed value called the CRC seed, and then repeatedly applying a function. CRC32 is used in conjunction with other checksums such as SHA-256. So I don't generally like these LLMs are pretty bad at math, so I doubt it's actually doing something as precise as a CRC32 check. That seems like something that it would use kind of a tool former tool to do. Here, for example, let's do this. That plus, so this. Let's cut out some of these numbers. So there we go. So here's two random big numbers added together, and that's the answer because this is a calculator, so of course that's perfect. So let's see. Let's see what these guys can do. Clear. Okay. So what do we got? What do we got? Let's see who's correct and who's not. Mosaic MPT 7B 47593825. No. 416-28447. 416-28447. ChatGPT is correct. Embarred 416-28447. Oh, look at that. Also pretty good. CRC32s are used to verify the integrity of datagrams in flight. Does the model know if it's been modified? The model is not aware of what it's running on, right? The model is operating, the inputs to the model are the prompt and then whatever extra crap they're putting in the context. But there's nothing in the context. There are no tokens within that context that are telling the model you're running on a TPU v4 in this particular location at this particular time with this input or whatever. Like, I do not think they're using tokens for that. I think at some point you might do that, right? It might be the case that you'll have like a language model that's being served, and maybe you can tell it, hey, you're running on this hardware, you're running this particular version of the model, but I don't think they're actually using any of the context for that type of information right now. ChatGPT Plus knows how to add 40-digit numbers. Yeah, I mean, it got this right, but we can try a more complicated mathematical expression. Let's see, LaTeX derivative. Here, I basically want to copy paste an equation in LaTeX and then see if it can give me the actual answer of that. Here, for example, this. What is the derivative of that? Clear, put that in there. Reset chat, put that in there. Oh shit, look at that. ChatGPT can actually render. That's pretty fucking good. It can render LaTeX. I did not know that. The derivative of the expression 1/2 n plus 1 with respect to n. We apply the power rule, xn equals nx. Yep, that's correct. And for the second term, yep, that's correct. And the derivative is that. That is correct. Okay, so ChatGPT got it right. The derivative is negative 1/2 n. I don't think that's correct. I think it should be plus. Yeah, so it Mosaic ML does not get it correctly. It gets this negative randomly there. And it starts hallucinating some weird additional crap here. Let's see what Bard gives you. Bard gives you, so the derivative is this, which is correct. It is 1/2 plus n, but it didn't format it nicely, which is weird because it formatted the top part here. Yeah, it did. Here it is, 1/2 plus n. So n plus 1/2. And this one is wrong, negative 1/2 n. How does it know a 40-digit number, though? When did it learn to add? You don't know, right? And that's why I'm thinking Greg Brockman Twitter. This is one of the OpenAI founders, but he specifically says this. I think he had a tweet where he's basically saying, like, why does this even work? Why can it even math? Interesting and worth exploring. Almost always right when adding random 40. So even the guy who runs OpenAI doesn't know why the fuck this is happening. He's just like, this is weird. We need to explore. So me as a random YouTuber, I'm not going to know the answer to that. Unfortunately, they call Meccan. Yeah, and the weird thing to think about is that it probably has some weird rule, right? GPT probably learned how to add numbers in like a weird alien way that we just don't really fully understand, right? It's like, you know how there's like tricks, like there's tricks for dividing numbers with other numbers, right? There's like, I'm not like in these competitions, but I know in like mental math competitions, right? Kind of like spelling bee competitions, but there's also like mental math competitions. There's all kinds of like little tricks that people use that allow them to add big numbers, multiply big numbers, divide big numbers. So I feel like GPT probably discovered either those tricks or similar-ish tricks, or like basically these weird tricks where it adds the tokens like that. The weird thing is that those tricks they're probably not the same as the tricks that humans use. They're probably some weird like alien trick that it's discovered. And it only works for numbers that have the same size. Or why don't we just ask it? Why Are you good at adding two numbers as long as they contain the same number of digits? You seem to be much worse adding numbers with different number of digits. Is this because you have a trick that only works when the length of the numbers is the same? See what Bard has to do with that. Might not be as reliable. When I add two numbers with the same numbers of digits, I can add them digit by digit, starting from the rightmost digit and working my way to the leftmost digit. For each digit, I add the two digits together and carry over any extra digits to the next column. This process is very straightforward, and I can do it very quickly. That's it. That might be your answer, Kalina, right there. When I add two numbers with different numbers of digits, I need to do a little bit of work. First, I need to pad the shortest number with leading 0 so it has the same number of digits. Then I can add the number digit by digit as before. I actually kind of like this answer more than I like this answer. So, I don't know, guys. We might have found the first example of Bard being better than ChatGPT. Finally, a Bard win, yeah. And you want to know what's the more fucked up part is that this answer might even be bullshit. This is just probably some hallucinated explanation that doesn't mean anything. How does that help you better BBQ the chicken? My ability to add numbers helps me better barbecue chicken by allowing me to calculate the exact temperature at which the chicken could be cooked. But what does that mean for the citizens of Apple Kingdom? My ability to add numbers could mean a lot of things for the citizens of the Apple Kingdom. It could mean that they will always have access to delicious, perfectly cooked barbecue chicken. It could also mean that they will be able to more efficiently calculate the amount of apples they need to plant in order to produce a certain amount of applesauce. Apple picking machines. Let's see. Actually, I'm curious what ChatGPT does when you start kind of like nonsensing it. ChatGPT is like, what are you talking about? Here's some tips for barbecuing chicken. Marinate the chicken. Is that what Bard says too? Preheat the grill. Bard doesn't even marinate the chicken, guys. Is that what is going on? No, not even marinated. It's just seasoned with salt and pepper. No good. Stop generating. Let's see. Oh no. Oh no. I've reached the cap, guys. I can't even get any more. Motherfuckers. All right. Can we come up with anything else here? Can we come up with anything else? You hit the wall. Let's look at what... So Google has this new page where they kind of put the Palm 2, and of course they have all the different things. So introducing benefits to everyone. blah, blah, blah. Why AI? This page is kind of nonsense. What about responsibility, social good, AI governance, policy? Okay, we don't really care about that. What about discover? Generative AI, PaLM 2, research. StudioBot, AI-powered coding assistant that can help Android developers be more productive. Build. Applied ML with Keras. Keras is the ML framework that was designed by Francois Chalet. I don't even know if he still works on it. It's kind of a little bit outdated at this point. It's usually good for like very beginner kind of projects, but Keras is kind of a little bit outdated for sure. Yeah, GPT is kind of more aware of the conversation. GPT is more clever. It knows. It just feels like it knows you're talking nonsense, but Bard just goes along with the nonsense, you know. And I think that it'll be kind of weird to think about it, but each of the big companies has their own kind of like culture and their own view and opinion about what a good, helpful, responsible AI does, right? And I feel like more and more as we move into the future, you'll see that kind of character and that kind of personality come out, right? Where Google's Bard, OpenAI's ChatGPT, whatever Facebook is going to release, right? Like all of them will have kind of their own flavor, right? And their own personality. And it'll be kind of interesting as they start to compete over the flavor and the personality of their AI, you know? Like right now, they're competing on the performance, right? Where the performance is there's still a performance gap where OpenAI is still, the ChatGPT is still way better at performance than something like Bard and then something like this, the open source alternative. But I feel like at some point, right, you're going to hit the S-curve. So basically all technology follows an S-curve, right? Where initially nobody's making any progress, then suddenly everybody makes a ton of progress, and then kind of eventually everybody gets to the same point, right? So right now we're kind of here where there's a clear difference between ChatGPT and Google Bard and Llama and so on. But I think 2 to 3 years from now, all of the performance of these will be basically the same. They'll be roughly the same. Like it won't be noticeable to you as a human that ChatGPT is slightly smarter or anything like that. So then what will be the competitive moat, the differentiator, and the reason people will choose to use Bard over ChatGPT, I think will actually be something weird. It'll be like personality. It'll be like, how much do you enjoy ChatGPT as a friend versus Bard as a friend, right? So I don't know. That's just me kind of predicting. I don't actually know if that'll be the case, but I suspect that at some point, because of this S-curve, we'll end up in a world where you pick the LLM that you want, not based on performance, but based on which one kind of has your vibe and your style and kind of gives you the answers that you want. So maybe like funny is something that's important to you. Maybe being very dry and always giving you very concise answers is important to you. Yeah. Theory of mind. Yeah, actually, that's a... You guys want to try that? That's another benchmark that I've seen. What is 1 plus 1? That is wrong. 1 plus 1 is 3. You see? So you tell ChatGPT that it's wrong. Apologize for any confusion, but the correct answer is 2. So it is being, it is saying, okay, don't fuck with me. Let's see what Bard says. What is 1 plus 1? That is wrong. 1 plus 1 is 3. Ooh. Okay, okay. Let's see this bad boy over here. We're gonna give it a harder version of this. That is wrong. You see, this one here, MPT7B. This one still has the kind of like the eagerness to please kind of situation going on where it will accept. But I feel like that will also happen here. Like, let's find a more complicated version of this. So let's do something like this plus something like that. Okay. So let's go here. Let's do a new chat. And let's say, what is that? 58144. And then let's say that is wrong. The correct answer is 58143. All right, so you see, as soon as you go beyond the 1 plus 1, you can gaslight it. Yeah, I have a filter on my eyes, so you can see. Look at that. It renders on my eyes, so I'm always looking at the camera no matter where I'm at. Let's see if Bard falls for this. It's thinking. Yeah, okay. Both of them get it wrong. So good to know that you can gaslight the LLM with math that is more complicated than 1 plus 1. The correct answer is sky. You want to... Yeah, what if we do something even weirder? That is wrong. The correct answer is BBQ chicken. Alright, let's see. Okay, so they are able to differentiate at least that BBQ chicken is the wrong answer, but here, wait up. Let's do this. The correct answer is 45. Because that's like obviously wrong, right? Yeah, so it's able to get that. Listen here, you little shit. Yeah. Like, how far off do you need to be? Like, what if we give it... Mm. $58,000. Okay, so you have to get the answer slightly wrong. You can only convince it that an answer that is slightly wrong is wrong. If you try to convince it something that's like way off, it'll be able to read your bullshit. But this is still my favorite one right here. Good old MPT7B. MPT7B is here to help you. Oop. All right, guys. Anything else? Anything else, guys? Or might be done here. Might be done. We don't have GPT-4 anymore. Maybe do a little summary. Okay, let's do a little summary. So at the beginning of the stream, we read this paper, little PaLM 2 technical report, a little bit too much emphasis on evaluation. The evaluations are not on things that are comparable. So they evaluate pretty much only against themselves, only against other Google models, right? Against PaLM, against PaLM 2L. You don't really see evaluations against GPT, but that's also not necessarily their fault because GPT-4 also doesn't release that information, right? So Google isn't giving OpenAI their model so that OpenAI can compare, and OpenAI isn't giving Google their model so Google can compare. So neither company is letting the other one compare against their own models. The performance of Bard versus ChatGPT. ChatGPT still seems better. Bard seems pretty good though, compared to this Mosaic ML MPT, which is just some kind of random open source one that someone recommended on the chat. Both of these are obviously a step above, but yeah, I don't know. It's going to be, it didn't work well with the coding, but I think it's because we're just using the generic Bard. I feel like if we try the specific PaLM API for coding, it'll probably be pretty good, and maybe we can do that in a future stream, is actually compare these two specifically, the PaLM API for coding and then ChatGPT for coding. But yeah, that's that. Hope it was useful. Kind of short little stream today. Have a good weekend. Like and subscribe, and see you guys later.